There's a whole host of things you can do here. You can send low bandwidth image, medium image, high res image, low bandwidth voice, so you can actually do voice over this as well. How cool is that? Welcome back to the channel, guys. Hope everyone's doing well. It's been a minute. I haven't posted a video in a little while now, a few weeks or so. And the reason for that is I wanted to take a bit of time off to learn about something really interesting called Reticulum. Now, for those of you that follow along on my Discord and keep up to date with all the mesh radio stuff that I've been doing on there, you'll probably have seen me go on about Reticulum, and there's even a channel on there now dedicated to Reticulum. So what is Reticulum? So to start with, you've probably heard Reticulum mentioned alongside Meshchat as, like, you know, a way to create another kind of mesh radio network. But Reticulum is way more than that. Reticulum is actually a complete network stack. So fundamentally, Reticulum isn't just for radio networks. It can be used over any sort of connection, no matter how bad and unreliable the connection is. But since this channel does focus a lot on radio communications, I'm going to explain in this video how you can set up your own Reticulum LoRa node, also known as an RNode. So to start with, I'm going to show you what you can actually do with RNodes. So this is an RNode. It's based on a Heltec LoRa32 board. It's in a nice 0 Fox case here. Basically, that is running RNode Firmware. So I'll show you how to install that later. But for the point of the demo here, we've got an Android phone here which is connected to this RNode by Bluetooth. And this is running an app called Sideband, which is part of the Reticulum software suite. On the other side, I've got exactly the same setup. So you can see here, these two phones are not connected by the internet or anything else. They're just literally got all other connections turned off other than the connection to these nodes here. So what we can actually do here is we can select this one, Andy Hartford Mobile. You can see there's some signal reports there showing that, you know, we're receiving a signal from this one already, basically like a beacon, and we can hit converse. Then we can type in, you know, a message to be sent to that one. You'll see this one kind of chirp, and that one will actually receive the signal, and then we've got a message appear on the other side. We've also showed a delivery report there. So we can see here the message has been delivered. We've got a signal report there as well. So that works. Back-to-back messaging, private messaging, encrypted over LoRa. Yeah, what more do you want? That's absolutely brilliant. Well, what you can also do here is you can actually send other stuff. So you can, there's a whole host of things you can do here. You can send, you know, low bandwidth image, medium image, high res image, low bandwidth voice. So you can actually do voice over this as well. And you can actually do high quality voice or just send a simple file. So for this particular demo, what I'm going to do low bandwidth image, and then I'm going to pick something from my camera roll here, which I think was just a picture of the wall. Super exciting. And we're going to send that. So you can see the data transfers happening between the two nodes here, saying sending 100%. In any second, I would expect this to appear on the other side and say delivered. How cool is that? Let's show you the voice as well. So if we do, let's do high quality voice, and we'll do a little test here. 1, 2, 3, 4, stop recording, and then we'll go save message, and then we will send that message. Now this may take a little while because it is a 7.65K file. Now, you know, we're not saying that this is going to be the fastest network speed in the world. It's absolutely not going to be, because you're doing this over LoRa, which is a very, you know, low bandwidth, long range system, which isn't designed to, you know, replace Wi-Fi or anything else. That being said, this system can actually use Wi-Fi. So you can use Wi-Fi instead of RNodes with Reticulum. So if you wanted to create a very high speed network, you could do that just fine anyway. It's not a problem. Anyway, 7.65K has been sent and delivered. So we can play that back. A little test here, 1, 2, 3, 4. And you can hear the audio quality is really good. And that didn't take too long to actually transfer. So as you can see from the demo, this is incredibly flexible, and it's absolutely amazing that you can send voice notes from one side to the other like this over LoRa. That's not been done before. So it is a great achievement to have this working over LoRa. Now these will actually mesh together, these nodes as well, so you can create a mesh network of these devices, which is something that I'm working to do over here. We already have a Meshchat network kind of rolled out, but I'd love to try and encourage people to use alternative systems as well, and experiment with that, because this whole mesh scene has started to really captivate the imagination of a lot of people. It's a great hobby. So to get started then and get your RNode up and running, the bare minimum you're going to need is what I've got here on the desk in front of me, and that is a Heltec LoRa32 board, which is basically a common developer board. You can get these on Amazon. I'll leave the link below in the description. You might even have some of these knocking around if you've been playing with Meshtastic before, because these were kind of the go-to board that I suggested using for Meshtastic in the early days. You can also use rack boards as well with this, but for this particular setup, to keep it simple, I'm going to focus on the Heltec version 3 board, which I believe is probably the most reliable and most stable at this point. The other thing you're going to need is an Android smartphone. It is possible to use an iOS Apple device, but the latest version of Sideband is only available on Android, I think, at the time of making this video. So it's best to use Android for this demo example. I will say at this point, if you haven't got an Android phone, it is possible to use a PC or Mac. You can run the Sideband app on those as well, or you can even run Liam Cottle's excellent Meshchat app, which is multi-platform as well. But this guide, again, is just focusing on the LoRa32 Heltec board and an Android smartphone. So now that's out of the way, we can get onto the fun stuff. So the first thing we're going to want to do is get the RNode firmware loaded on the Heltec. So fortunately for us, Liam has made this really easy, and he's made this really cool web flasher, which is just an absolute game changer. So this allows you to flash your Heltecs directly from a Chrome browser. So fire up a Chrome browser, head to this address up the top here. I'll leave the link below in the description as well, or get it from the screen. And then you can just dive through these settings here and set up your RNode and get it ready for flashing. So first thing we can do here is select the LoRa32 V3 board. You'll notice there's loads of other nodes as well supported, but they don't all have firmware available for them as yet. And as far as I know, from what I've tested so far, the most reliable is the LoRa32 V3. So just be aware if you're going to try playing around with other nodes. Start with a Heltec if you've got one, because it will just make life a lot easier figuring this out. And then so down below we can select the model, which we want 868 for the UK, and 915 is there for the Americans. And then we can move on to the next step. Now you have to manually select your firmware file, but that's okay because it's on this link here. So if we click on that, you'll go to the official Node firmware, official RNode firmware, and you can see here we want this one here, the RNode firmware Heltec 32 V3. So if we just click on that, that will download that to my downloads folder. Go back to the RNode Flasher, click on the choose file, and then we can basically select that with the file we just downloaded, and then we are now ready for flashing. So now I'm going to take my Heltec, I'm going to plug it into the computer by USB. Oh look, it's got Meshtastic firmware on it. Not for long. So I'm going to hit flash now on the RNode Flasher. Hit CP2102 because that's the USB device that it's plugged into there, USB serial 001. Connect there. The screen has gone black, and we will see here the flashing progress happening as Meshtastic gets nuked and it turns into an RNode. Shouldn't take too long. Right, so when it's done, you'll notice that you'll get this little pop-up up the top here. Now, it's really important with this website to take note of these pop-ups because they'll tell you whether it's been a success or not, but also when the step has been completed, and that's kind of what you need to be sort of paying attention of in the next step. So you can see here the firmware has been flashed, but it actually says firmware hardware failure. That's not a hardware failure in as in the sense that it the hardware is broken, so don't worry about that. It just basically means this step here, you need to provision the EEPROM in step 3. So we'll hit this OK button up here, and we need to go to step number 3 and hit provision. Again, select the USB serial port, hit connect again, and we'll see this provisioning starting to happen. This can take a little while, and you have to wait until this message appears up the top of the box, top of the windows rather. That's what you really need to sort of pay attention for, because you might think that it's done it, and it hasn't actually done it. So we see here device has been provisioned. That's okay. You see we've got some extra boxes on the screen now. but there's one more step we need to do, and that is to set the firmware hash. So if we hit that, and then back to the select the serial port again, hit connect, and there we go. Device checks passed, and it's all ready to go. So we also see this firmware hash has been set at the top. So we are ready to go with this device then. You know, this is not going to transmit anything at this point, because basically the way this works is these devices are just simple radio modems. They don't kind of do any heavy lifting. The software is all done on the smartphone on Sideband. So basically all the hard work is done by the smartphone. This is just simply a radio modem. So you know, it's not like Meshchat where this will start showing you messages on the screen that it's received off the mesh. It's literally just a radio modem. So without Sideband or any client connected to it, it's not going to do anything at all. So with the device prepared and ready, what I'm going to do is just hit the program button on the Heltec, and you see the little Bluetooth symbol come alive, and that means obviously the Bluetooth's turned on now. And that's basically the next step. We want to pair our smartphone with the Heltec, so we can hit pair here, and we should find it. This should be this one here, 5F28. Now on the screen you might find you have to do this a couple of times, and you can actually trigger the pairing mode by hitting, here we go. So I've had to hit that a couple of times, but anyway, we get there eventually. You can see the pairing code on the screen there. So it's 882681, and we're just going to pair that. Let that do its thing, and it has done it. And you can see the Bluetooth logo on the screen there has changed to a sort of Bluetooth Connect. So now we need to set up Sideband on the Android smartphone. You can do that by going to the Sideband page on GitHub, which I'll leave a link below to as well. So if we just scroll down the bottom to the releases section of GitHub, and we should see 52 releases there. 1.2 is the one we want, and we can get down to the APK here. Tap on that, and we can actually download it. So I've already downloaded it before, but anyway, we're going to download that file, and we should be able to open that and install that once it's finished doing its thing. Okay, so it's downloaded. Hit that to install. We're going to install the Sideband app. See, all of this is great because it's not gone through the Google Play Store or anything like that. Open up the Sideband app. We allow it to run in the background. We can close out the guide. Now, this is the important bit, to set up the Sideband app. Now, one of the things you should know about Sideband is when you change a setting, you do need to restart the app. And that is usually done by hitting the little menu button up the top, so you get this side menu pop up, and you can hit shutdown. So whenever you change a setting, it's a good idea. It is pretty important that you shut down, because otherwise it might not apply the settings correctly. So what you're going to want to do first is set the connectivity settings. So you can see here, you can connect via local, so you can have Sideband running on a Wi-Fi network and talk over a Wi-Fi network if you really want, or anything like that. I'm not connected to Wi-Fi, so I'm just going to leave that as it is. You see here RNode, we want that basically enabled, connect via RNode. So we will do that, and basically we can make some other settings changes before we do a restart, but we want the RNode enabled there anyway. Then we can go to hardware, and what you want to set here is the RNode information. Like, this is where you'd set your frequency and everything else for the radio. And in the UK, we're using this frequency at the moment, 867,500. You want your bandwidth to be 125 kilohertz. TX power needs to be 22. Spreading factor needs to be 9, and coding rate needs to be 5. Now, these are sort of settings that we've kind of just settled on in the UK based on, it's just kind of, that's how it works. It seems to work the best way, and it kind of abides by the licensing conditions as well, because you've got a narrow bandwidth there on this particular frequency. So that's all you really need to do for that, apart from you need to activate these, because you want to connect it by Bluetooth there. So you can then exit that screen and then shut down the Sideband app. Okay, and then we can restart the Sideband app, and what we should see, all being well, is this node chink into life once it starts. There you go. So that's working. You're going to watch out for this screen. Just make sure you get this scrolling waterfall kind of display there. That's showing you that it's obviously working and connected. If you get any of the LoRa settings wrong, it won't start. Any settings that are just a bit off or something like that, it will mean that the RNode will just not start. So you won't see this screen. It will just say firmware, whatever the firmware version is, and it will just sit on that. But you can see here we've got airtime. We've got up the top here, it says, it doesn't say connected, but it says on at 1.8 kilobits per second. So we are basically online with this RNode now. You can also check your RNode status by hitting that there, and it will actually show you RNode on air at 1.676. It also shows you the battery level, a little bit low on this one. Actually, I think it's just because it's on the on USB power. So other things you can do here in preferences, you can actually set your name as well, because it will just be anonymous peer until the point you change it to say Andy Mobile 2, whatever, and obviously then you've got to restart that again to obviously apply that. So we'll do that. So to start to show you how this works, I've got the other device here. This one's obviously the one that we saw in the beginning of the video that's already been set up. So that one's all set up, and this one's obviously all set up as well. Now, before we can do anything else, like connect to the other node and send pictures and all the cool stuff that you saw in the beginning of the video, you need to do a thing called announce. And basically what that does is announce your presence on the network and exchange some essential information with the other nodes on the network so that they can contact you as well. Also in this is like the routing information. So it knows, in complex networks, it will know how to reach you based on that last kind of announcement packet. It's really, really clever stuff. But all you really need to know for now is that if you hit this button on the top here, it will send out an announce, and that will make your node, this node, visible to the others on the network. So how do we see other nodes that are visible on the network so far? Well, we can go into the menu option here, announce stream, and every time you get an announce, it will show in the announce stream. And you can see here, Andy Mobile 2, you've got an RSSI and signal to noise ratio, which really helps with like antenna situations and working out, you know, if you can connect to these nodes reliably. Vice versa, it will also do the same the other way around. Of course, if we announce on this one, you'll see it appear in the announce stream on the other side, and you can see exactly the same there, signal to noise ratio and everything else. Once you've done that, you can actually hit the menu there and go converse, and then basically type a message in there, send it, and it should appear on this side as well. And that, in a nutshell, is how Reticulum works with Sideband and an RNode. The way we've got this set up right now, we can see that we can send direct messages between nodes. It will work with any number of nodes, and you can send direct messages between all the different nodes in the network. You can't do group messages the way this is set up. There is a way of doing it, but it's slightly more sort of complicated. And there's not such a thing as a broadcast network messaging chat like you have on Longfast for Meshchat. So it's more geared up for direct messages at this point. That will probably change in the near future. Also, the way this is set up, these aren't going to mesh together. There is an extra setting that we can turn on, and that is called Reticulum Transport, and that can be found in this menu here. So if we go into the connectivity menu, go right down to the bottom, and you can enable Reticulum Transport. So say, for example, the middle node here was the transport node. You could then connect through the transport node to reach, you know, a distant node. So you can do meshing that way, and it does work very well indeed. Be aware though, only use Reticulum Transport for static nodes, base station nodes, and nodes that are kind of, you know, in really good locations like tops of hills and mountains, that sort of thing. It's not advisable to use it for mobile nodes. There's one thing I forgot to mention, because this video has been a bit of a brain fry, and that is to turn the advanced metrics on in the preferences of Sideband, and that will give you then the RSSI and SNR on your RNode stations. Just something to be aware of if you don't see that. And that brings us nicely to the end of the video. Hope you guys enjoyed it and it hasn't fried your brain too much. I know there's been quite a few people asking about Reticulum and RNodes and the activity on Discord. We've seen, you know, more and more people joining that conversation there. So if you want to know more about it, feel free to obviously skip the video and ask questions in the comments, but Discord is a really good place to discuss this. Obviously my Discord, I'll leave a link below to that and you can check in there as well. But yeah, it'd be really cool to see some RNodes pop up. I think the easiest way to set up an RNode at the moment, if you're thinking of doing it, would be to use some sort of loft mounted antenna like an Omni or preferably a Yagi with a short run of very short run of coax, because the losses on these frequencies are quite high. Have the Heltec in the loft and then, you know, Bluetooth down to a phone, you know, in a lower floor of the house. But obviously you are going to be restricted on how far you can go because of the range of Bluetooth. I'm going to do another video soon about how to set up a Raspberry Pi node, which makes things a lot easier, that you can connect to Sideband directly over a Wi-Fi network, and then it will obviously go out via LoRa. But currently I've got a Raspberry Pi and a Heltec on the top of my mast over here, and that is using a Yagi as well. So hopefully some of you guys will pop up in the not too distant future, and I'll catch you on Reticulum. Hope you've enjoyed this one, guys. Catch you next time.